Okay. Thank you so much. Thank you, Pydata 2026, for giving me this opportunity for this tutorial. We'll kickstart with this. So we'll talk about today about making databases LLM ready. So what would that mean, basically? So as I had before, any questions are welcome. I'm not here to lecture you or anything. I would like you to kind of like understand the philosophy behind what I'm trying to say, how did Semantido came to life, and actually the principles behind it. Because if you don't choose to use it or anything else, you might want to build your own. So, but it will kind of like give you the first-hand principles of how to build a semantic layer, and we'll understand what the semantic layer will be. Now, we'll start with, because it's 9 o'clock in the morning, so why not? That's the philosophy. Use no way as way, and have no limitation as limitation. So it's very important because we'll see during the tutorial that there are several approaches how to build those things, and some are, and you'll understand what are the, in a way, architectural trade-offs that you need to do in order to make those systems work. So that's why no way as way. But there is a way, the way of the semantics. So Semantido is, again, 9 in the morning in Japanese. So this comes a bit from the history of how this actually came to life. This came to life 2024 when I started to train boxing and a bit of mixed martial arts. Around that time, I wanted to track my own, let's say, performance during those trainings. And there were also the world of the first agents. Like, why? How can you use, then why not use an agent to actually do whatever you need to do? Summarize your training, suggest some improvements or things like that. But I hit a couple of walls, and those walls we'll discuss during this training, and as well how I surpassed them. And in that way, for 2 years, how to build actually a semantic layer. And as I said, we'll talk about what the semantic layers means. The agenda will go what are semantic layers, why Semantido. We'll switch a bit to some of the things that there will be in the tutorial themselves, but they are in couple of articles that I wrote about it. And the last one is use Semantido to build one. So we'll touch real code. We'll look at not the typical, and I don't want to bash anyone, like 2 table scenarios. We'll look at a bit more tables with bridge tables and see what failure paths an agent might have when it has no clear path on how to actually select or join things. So it won't be a 2-table tutorial, so that's for sure. So your host of, me, Dragos Crintea. So, and as I said before, this talk is a personal reflection of my own experiences, and it does not represent any of the employers' views or things like that. So legally speaking, so to be there, this is really my way towards trying to build a semantic layer and build something that it will allow you to move towards what's called agentic analytics. And that is basically what we'll see towards at the end of the tutorials. How will actually build an agent to do that. We'll use Pydantic AI for that. Samuel Colvin is one of the keynote speakers, so yay. So not because of that, but it's a great framework to build this type of agent. And we'll start slowly. So the observation that I have over the years was that mostly, so I work with small businesses, medium businesses, large businesses, name it. And most of their data is stored in one of these pretty much 5. SQL stores, document stores, Confluence, plain old document files, either PDF or Word or anything like that. So, and there was quite a lot of, let's say, buzzwords and also a push. How do we actually do this kind of things? And we had that RAG systems, retrieval augmented generation. We had the all the vector stores, let's say when everybody was putting their documents into some sort of a vector store and then start querying them. And the answers were, well, mixed. So in some cases, you'll have good outcomes. In some cases, you might have hallucinations and whatnot. And the question was that, so how do you make those things more reliable? We have a large language model is by nature a non-deterministic system. So how you try to make it a bit more deterministic? How do you actually ask to cite to ground its answers and things like that? And that, for the past year and a half, was quite an interesting story to leave. From the very early exuberations to, it doesn't really work. But the question is that how do we make it work? And one of the ways, and there is a bit of a mixed up what the semantic is, because you'll have semantic search, and you have semantic layer, and you have semantic. So what is actually semantics? Yeah. So two things that I actually went through, and I came across two books. So Semantics in Business Systems. If you look at the publishing year, it's 2003. And we'll see some images from that book. So I asked the author for the permissions to actually use those in an article that I wrote. But you'll see that actually in 2003, people were actually thinking about agents. They were thinking, but different type of agents, but understanding what that how semantics will play a role in natural language understanding. And this kind of like started everything. The second book is Semantic Computing. That was published in 2011, not too far away, so 2003, 2011, we're in 2026. But you see there is a 15 to 20 years gap between what people were talking about at that time and more or less a representation that we see today in today's architectures. And that was a surprise to me. So I was like, okay, I thought that this is very new. Well, not really. And that's the first one, right, from the book. So this you can download the first chapter from research.net. So the link it will be when I'll share the article, the presentation under. So you can actually, this is freely available from the book. So you'll see that looks interesting, right? So you'll have text, multimedia, structural data. And one thing that actually becomes very interesting later down the road, and we'll see why, we have programs. So there is a mixture. People think only that the data resides or the understanding resides only in the database, but that's not actually true. Completely true. There is true, but there is not complete true. A lot of the meaning of how that data is processed or generated is in the application itself. And that is something that actually is one of the keys that Semantido tries to actually come across. To work on it. And the definition is like, we define semantic computing as a field that addresses the derivation and matching of the semantics of computational context and that of a naturally expressed user intention to help retrieve, manage, manipulate, or even create the content, where content may be anything, including video, audio, text, process services. That sounds like an LLM, huh? So yeah, there was no such thing as an LLM in 2011, nor in 2003. However, that's basically an early design of an architecture from back then. And then there is a semantic analysis, there is a semantic integration, and there will be a semantic services, which we have semantic search. Now, that is the thing that came to fruition much faster than anything else that we've seen before. But you'll have that semantic information that is pushed by different subsystems, including programs or structural data, which in this case is a SQL, and some sort of a semantic integration. And again, that's one of the things that a lot of even the current frameworks do not really look at that. Then you'll have semantic services, which we QA systems. Wow. Well, yeah. And then we'll have service integration, which you have service integration agents. It's important to mention that agents at that time do not mean the agents that they are today, but some sort of an agentic system. And you'll have semantic interfaces with natural language where people can ask things. Well, they saw the future. So, and then you'll have the security and management. And this is also very important. How do we actually have access to those things? Because if you let loose an agent over your database, well, in some cases with not the right permissions, they might delete it, as we know, and not cool. So, and how do you manage those accesses and those permissions? Now, if you go to to the next one, you'll have what's called in this particular way semantic computing, and then we'll have that one. So multimedia, so multimodal, image, voice, text, program process, structured data systems, and then you'll have artificial intelligence, natural language, knowledge and data engineering, software engineering, and whatnot. But we'll look at the first two, right? So those particular ones will be, better. So, so those particular two are interesting to what we actually will look today into. So, okay. Now, semantics is like tomato. So, you've seen technically we have different meanings of semantics, and basically it is the study of meaning. So it's kind of like an oxymoron. Sorry. But that is, so what is, so, and that meaning gets totally muddled in different, let's say, facets of it. And if we look at Dave's book, we see that semantics is often defined as the study of meaning of words, but we are going to take the broader definition, allowing for the possibility for meaning to reside in something else other than words. Ultimately, the relevance and success of our application system rests on what the symbols that we are manipulating inside the computer really mean in the real world. So, of importance is not only what they mean, but do the people and other computer programs that deal with the presented information understand and agree with the meaning as implied by the system. So that becomes very, very interesting in the world of agentic system. What does the system, in this case, understand the intent? And that is, well, a thing, right? So we had prompt engineering, we had context engineering, and now we have harness engineering. And we'll have next something, I don't know. But ideally, we've seen that also in a leak that should not mention. We see that actually the large language models is only a very simple part of it. It's not that much. The harness around it actually plays the most important role in actually building the whole thing. The language model is more or less supporting the application rather than actually driving it. It's a bit of a flip of what, at least in my mind, what people understood when we talk about large language models in like, oh, we can ask a question or we can build a small agent and do this and that. However, the most important part is like what happens around it, not actually the language model itself. As I said, any questions, anything, stop me, because this is something that is 9 o'clock in the morning, so and I went a bit faster than I thought that I would do. So if we are to move a bit forward, we'll see that basically how do we define semantics and where the role of semantics is in the whole picture, right? So it starts with metaphysics, funny enough, and it goes through ontology, semiotics, and semantics. You'll hear people talking about ontologies these days, like how to build one, what to do with it, and things like this. However, ontologies are based on semantics. So my feeling is that they are a bit like flipped. So semantics concerns itself directly with what something means. So if you do not know what that thing means, you can't really build a correct ontology for that. So starting from the ontology and then applying semantics is a bit backwards in my view. So if we look like the direction of travel from what that actually means. And that's why I thought that, so subject matter experts and things like that, they have a broader understanding of the system, and we will see later there are two views of the system. It is basically the application context, and there is the business context. So the application context means what the system does. The business context means what the business does with it. Two different things. And they were never put together, I mean, so far, not that I have seen. And if we look further, this is what we just said, application, data, and business context. And I said, in my opinion, a source system will always be the ground truth. It will contain both the application, so the encapsulated business logic, and the data it stores. most likely in tabular form. Can be document as well, but that doesn't really matter. It will be some sort of a data structure that supports that system. And I believe trying to separate them would contribute to the loss of meaning and how we would interact with the data produced by the system. So if we look specifically only to SQL, to tables, do we really understand the system itself? Why that table exists? Maybe yes, maybe no. So it's a bit of a, yeah. So I think that all three together actually should form when we describe something, particularly when we feed something in context, what that actually we mean by it. So, and that's one of the other part is, that also comes from Dave's book. And again, that was an interesting thing in 2003. The red part is overlaid with what this will mean in an agentic world. So we'll have the semantic interpretation and the semantic origination. So you'll see human to human, human to agent, application to human, application to application, so, or agent to agent. So, and that is actually maps quite well in how do we want to interact or represent the systems in one way or another, right? And so we know when we talk between us, there's always misunderstanding. So you need to really make sure that you mean what you mean. Now, well, if you do not specify that enough to a system that can actually, make up stuff, you'll have some problems, right? So, and how do we guide the system, or how do we guide the language model or anything that we want to do to actually figure out what we really want to say? Tell me what you want, really, really, right? Not kind of like, and that way we see the prompt evolutions, like from really single prompt, single lines to a bit more describable. So like the oldest prompt engineering thingy that they came across, and trying to make the system a bit more reliable by providing that information in context. And this is what it actually is called in-context learning, right? So the system will see that for the first time, something that you actually bring to it, and try to figure out from the information in the RAG systems what to retrieve back. So that's no magic in that. However, you'll see that the red part of agent to human and agent to agent will be like, okay, so now we have an analytics agent which will need to do something. So how do we make sure that the thing that calculated or the thing that retrieves are actually the ones that we want? And how do we, in some cases, introduce human in the loop for actually making sure that that is the case, which is not always the case. So the other side is like a very, 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 very simple. However, agentic semantic architecture we'll go through in a bit more detailed one. But technically, you'll have an application glossary, an application data, and then you'll have your semantic layer service, and then you'll have things that they can connect to it, which is an MCP, an A2A, and then you'll have governance, which actually looks. So they connect, but the governance feeds back in. So one of the things that I noticed, and I mean, I'll ask your opinions as well, is that most of systems will try to govern their data in a more centralized fashion. I think that's a good idea. I also think that's a bad idea. So, because those systems will be always, in a way, later to realize what happened in the original, so in the source system. There will be delays in how can you update your, like Collibra or anything else. Nothing against them. I'm just saying that there is a delay in how do you push those things upstream. And I always believed that you can actually have a system or have the representation of that system metadata to be freely available. You don't give access to the system itself. You just give access to the representation of the data. And that can be provided via a semantic layer service attached to it, whereby an MCP or an agent can connect to it, or even a fast API. It doesn't really matter. It's something that you retrieve, and you know what is actually the system providing me. And I don't go to Collibra, or I don't go to somewhere else. I just go to the system itself. And in this world of, let's call it agentic, if this world flies, well, that is quite interesting, right? Because it won't really go, so it will actually, you can create, in a way, a semantic search in this case, when you say, okay, I want to retrieve information about something. And then the system will try to find from all its let's say, components, where in which tables, in which system we should go, and then compose that information. Now, that's the other side, because you will have another problem. And the problem is that how do you deal with multiple schemas, and how do you orchestrate those things? No? So that's something that you'll see in the world of like, oh yeah, I just put a dashboard together. Yeah? That assumes that the data is in the same system all the time. Is that correct in real life? If you have it in a warehouse, maybe, but not really. So it's how do you actually bring that let's call it action, or whatever, let's call it interaction through that system would be in this world, close to actually back to the source system. Now, governance will dictate if you have access to it, if you can actually query it. But that's a different story, that's a different path. So that's something that I try to kind of like, and those are the learnings that I've done for the past 2 years. When building even a very small gym application, the one that I mentioned to track my own workouts and things like that, which is agentic, believe it or not. And then we'll have basically, that's where the whole thing, and this is what we kind of like, we go into the meat of the whole of this tutorial, text-to-SQL. And it's a very deceptively simple problem. You'll hear articles, SQL is solved, everything is solved, let's all just take a break. I do not believe it. There are a lot of problems. Yes, a large language model can generate a SQL query. That's not the point. The point is that is the right query. And then we'll see that actually there are quite a lot of problems around those things. And as I said, this comes from my own experience. If you build those systems, I would really love to talk about with that, right? So and then, so if you think about it, what were the challenges for this, even now? And we kind of like discussed about it, right? It's application and business-specific context. So how do you provide both the application and the business context in the context of that query? So how actually could they come together? So, and some people do it in one way, other people do it in different ways. However, this is one of, I think, one of the most important things that we have to consider. Now, the other one is understanding intent. It's what we just kind of like put it. So the whole thing has to be intentional. So by intentional meaning, like if I'm asking, the question is like, there was the very simple question, show me all my revenues for the quarter, da-da-da. But then it means that in some system, that means that the revenue is actually a subtraction between whatever and whatever, but the system doesn't know. So some LLMs might know, some might don't, depending on how thinking they do. But without any additional help or that particular guidance in some way or another, they won't provide you the answer. Now, in this world, there are two very big approaches to this. One is create a prompt that has all the information in there. One way. However, that is slightly very brittle. I won't do that. So, and the other way is kind of like putting that information in some sort of a system that is available. Again, you have other issues with that, and we can go into those discussions as well. But understanding intent is very hard, and then we'll talk about a bit productionizing those things when we talk about evaluations and evals and whatnot, the hot topic these days. But ideally, it's really understanding intent, and this is again a problem. So how would the system? And I don't want to say anything, but most of the systems that are trained are mostly on English language. Now, I'm not a native speaker. I did speak English for 17 years, but sometimes I cannot express myself very well in English. How can I make that one understand if I can't? So that's another problem. The other one is actually, we call it SQL limits and when to be agentic. Now, you can describe things in SQL, but you cannot describe everything in SQL. So complex questions, which they will require, CTEs or windows or whatever, they might meet the SQL limits, and when to be agentic is basically, again, another question. So where do we actually start to think about being able for an agent to let it generate some code and compute those things for us? Retrieve the data, compute it, and actually send it. Where is the limit of that SQL, and where a standalone, like a build and throw away thing will start to be interesting, right? Because if you start to ask, right, relatively analytical questions, would SQL be enough to solve them? Maybe not. So the question is that how do you pass the context between the query itself, the resolvance of that query, and then the analytics part that comes after in an agentic workflow? And those things are becoming, real questions if you want to go that route. Now we'll look today only on the SQL itself. We don't have time for the agentic part, but it's kind of like food of thought. If you ever build this type of agents, how do you actually transfer that context in a way that is seamless from one to another? And yeah, that's another thing. Yeah. And the other problem, which we've seen it much more happening these days than in the past, tokenomics. Well, context does matter, and it's expensive. So I think the token max era is kind of going slowly to an end. So you'll have to pay for the things, and those things won't be that cheap. Yeah? So unless you're running your own language models, open source ones like Mistral or Llama or anything that you can actually control, then you basically are able to kind of like maintain a fixed cost, so to say. However, if you are relying on Anthropic or OpenAI, the more you put in the context, the more you think, the more it gets expensive, and then the more that conversation goes. And we know the story by now. So again, there are larger models, better models. However, the context does matter, and it will cost you money. So, and if you have 1,000 analytical queries with 1,000 agents running, how much would that cost you a day? No, those questions they start to become very relevant. Let's put it this way. Now, before we go into the code, and we'll see how this kind of like works. We'll look at what I mentioned is that there are many failure nodes. I picked only 3 for this particular tutorial, and we'll see why a large language models will take a path that it's supposed not to take, hopefully. And we'll go through basically 3 of them. One is bridge fan out. So what does that mean? It means that any question that contains a grouping dimension sourced from a mapping table, so we'll go into SQL very soon, alongside a balance measure. So questions like by product, by card type, accounts with X enrolled, customer who have Y, will most likely in real life will trigger a path through a SQL, so to some sort of a bridge table. And if that bridge table is not good enough, then or you have different other ways how to arrive to that question, the large language models will basically pick one of them. So if it's not deterministic enough, that's the path that it should pick up. So so bridge tables are important. So and this is by important meaning like they will kind of like silently give you these errors. Yeah, so most of the things that you'll see at a very and very well named table. So we'll see that I was not fair to the large language model, let's put it this way. I prepared a table. I also asked Claude to help me a bit because I can't use any other information, so to say. So I'll give it like high level how I want to look at like. And basically kind of like providing like inconsistent column names, inconsistent table names, things that you always will have in legacy systems. If you're working on new systems, good luck. Hopefully you'll have proper table name conventions. Most of systems, they don't. So they will be organically evolved, and the ones that we really want to extract data from, which are actually the most important data for the business that we talk about, they're not really newly built. Or if they still have some sort of discrepancies in how they operate or named by that. Now, sign conventions. So, oh, and I forgot to mention. So we look at the banking application. Initially, I thought to look at the gym application, but that was, nah. So I was like, okay, why not? Because everybody uses banking as an example, you know. They are the first one to use it, which is maybe not the case. So sign convention. So it splits into risk. So questions about net flow, net position, running balances will almost certainly produce a wrong island. So net implies sign arithmetic. So so this meaning, this transfer of the meaning to what that actually is, we'll see how it's actually solved through some sort of it's not black magic. It's basically the mixture between application and business context, and how do you actually bring those things into the tables to resolve this these inconsistencies. Questions about spend or total activity, more dangerous because sometimes land on correct results. Because there are type of transaction types, right? So and they might be, so you need to have like debits or credits or return or refunds or whatever. So there is a way. How do you actually create that so that you'll have the correct? They're always net positive. The amount is always net positive. However, you know, like you have debit or credit or whatever, they will just put a minus but the amount itself is always positive. And balance ambiguity. So, for example, balance is schemas has, in this case, is a specific case for balance. However, schemas, or in also real-world application, when we talk about account in different in different business contexts, it might mean different things. It's an, like a debit account. It's an account for a person. It's an account for, I don't know, for a general account for a company. So all these kind of things, they have different meanings. However, they're all called account. So, and in some cases, when you say balance, and the schema will have two columns with different semantics, which one? No. So without any guidance, it will pick one or the other, and they will always produce a plausible number. Is that number correct? So, and that you can catch it up with basically with evals, evaluations of the systems. I don't say they will always catch them up, but you will increase your probability not to fall in one of those. We'll go to, let's say, a bit more. So, kind of like what we discussed before, right? So, and this is this. So, the way how I approach this and the way how I thought about Semantido as a semantic layer service, it's just basically provided by the database service itself, or some sort of a service that has access to its basically to its underlying tables. So you won't need as per se anything else than just a read to those tables. That's about it. And then basically the access to the let's call it to the SQL alchemy models. Now that is the other side of the world, right? For the moment, I work mostly in the SQL alchemy world. Most of the things that I've done is SQL alchemy, and that's why I picked up SQL alchemy. But the reason why I wanted to walk you through the philosophy of it is that if you want to apply it to anything else in JavaScript world, God forbid, you know, Prisma or whatever, then by all means, I think the knowledge is transferable to that. I didn't do it for that. I just focused on the Python world. And the reason I think, so we apply this for like two reasons, right? So you have schema migrations. So those are the two parts that basically you take. One is that providing that semantic layer access, so the top one. And then your migrations, your semantic layer and your DB state will always be in sync. The moment your Alembic will run, they will always produce the new semantic layer. So there is no delta between the two. There is no upstream push. There is nothing there. It's just that you run Alembic, generate that is new. Simple as that. So there is that. I think it's quite okay. I mean, I'm here to correct me if I'm wrong. So I'm not, as I said, I'm not postulating this. However, I think that will not. And if you want to push them upstream after that, that's fine with me. I don't mind. But the first thing is that your semantic layer will be always up to date to anything that database has. That's that. The other side is that any analytics agent, be that standalone agent or be that through a chat interface, which we'll see today, they will have some sort of a workflow and some sort of an executor. And be that agentic, so the deterministic or agentic, either one. We'll look on a deterministic one today, but they will have, for example, the analytics agent might have an execution right to the query engine. So one of the things that potentially the service might provide or itself can provide is sending a query to that agent. And most systems, you'll think about it like fronting it with some sort of an API, so you don't really give database access or things like that. Or you can provide, let's call them security controls around it. So basically the agent should either be that as a system like a service token or a service-to-service authentication, which will then basically have the rights of the user, in this case an agent, to do whatever you have on your column. Go ahead.
The part where you mentioned about syncing no delta between the database and the semantic layer service, could you clarify what that means? Does that mean that every time we do a query, we generate the schema migration?
No.
Or do we do it every time there's a change to the database that we then trigger?
The second part. Every time when you actually update the table, then the semantic layer is basically, you can do two things to that. So you can either cache it and then just push the cache immediately or invalidate as soon as the table changes, or you can say every single time you need a query, just go and get the semantic layer. It's an API call, and that will be like this. It's 20 milliseconds on any decent systems, right? So it's not.
Follow-up question. So this is the tricky part, right? Like, do you use an LLM to generate the schema from the database?
No.
Or is it like?
No, I'll show it to you. So this is, no. So that's the thing. So this is basically the semantic layer so Semantido is in charge of generating that semantic layer. And that's why I kind of like walk you through the philosophy of it in order to see why that is built like that. Because I said my aim for this tutorial is not, I mean, I would be loved if you use Semantido and tell me how wrong it is. But if you learn how to do it, you can actually do it yourself. So it's a win-win either way. So going back to the security level, that's the other part, right? So you can expose that particular semantic definitions through any like read-only capabilities without any problems. The other side is that you can actually kind of like provision any agent with kind of like workload identity or service accounts or anything that it's allowed to access the service itself. And then on top of that, you basically can produce let's call it the credentials that it can from that schema can only access specific tables or things like that, right? So if you have like Neon or Supabase or any Postgres, you have row-level security, enable or RBAC accounts or so access-based, role-based, name it, then it will actually reduce let's call it what type of data it can access and how. And that is as well important.
So when you say that, like, for example, it's read-only, is it like we detect what code is being generated by the LLM, and then if it's like typing something, we block it, or is it something that's happening within like these Neon these platforms which don't allow certain code to be executed?
It's actually both, right? So you'll give only read-only access to a read replica, for example, or if you can't do that, you will force in the prompt, so you'll have a layer security in a way, and then we'll go through the executor prompts and as I said, it's kind of like it's a layered approach. Always security is layered. It's not in only one place. So I say, okay, I reduce the amount of how this system can access, then I reduce the amount through a read replica. If I don't have a read replica, then I give the account only read properties. And if I can't do that, I need write specifically, then I go even more further and say, okay, I restrict that through either prompts or either things like that. So it's and that's the code base we'll go through, and then we'll see how that actually runs in. So the reason why I mentioned production ready is particularly for that, right? So it's not something that you just kind of like, oh yeah, just let's do it, and we don't have any security in mind, or we don't have any controls, or how do we deploy those things and whatnot, right? And how do we actually make them accessible over the I won't say internet, I will say the private internet that you might have internally, right? So that's basically where this goes. It's not, yeah. So at least that was the intent of all this. The other side is that if we look, so all these players are in the semantic world, all of them. And then you have different, and this is what I mentioned at the early beginning of the talk, you'll have different architectural choices if you pick one of those, right? So it's and we'll go a bit through, I think it's open, the article on the side just a bit, to kind of like look what they do, right? So you'll have the heavyweights, which is the Power BI and LookML. Actually, those guys invented semantic layers, really, they did. They didn't call them like that, but they did. So, and in particular in Power BI, because I did work a bit with it, you'll have basically Power BI objects, which they maintain that representation of an object. But that's again a problem. Then how do you make it transposable to any other system that they want to access that? You have DAX, very powerful language. Does it really work with these agents now? I mean, I hope Microsoft will do some things, but yeah, that's another story. Now we have then, so this is one part of it, right? So, and we look at basically where they are, right? So it's above SQL and inside data platform. So above SQL means that they will generate some sort underlying, but it's their proprietary. So if you look at LookML, so you have Looker, which has LookML, is that proprietary language that will do that things for you magically, which at that time, amazing, yeah. And then we'll look at like the categories. So we have BI native, we have headless, transformational, open standards, app native, and warehouse. Those are basically BI native. Those are the business intelligence native. And this is what I think we have to really draw a line in the sand between what is a BI native and what is actually agentic. They are not the same thing. I mean, not in my mind, and correct me if I'm wrong, like really. In my mind, they're this way. Yeah? So one is agentic system, one is human interaction. How do we mix the two? It's a different story, and it's another problem to solve. However, them themselves are totally on the BI native side. Now you have headless, which is basically Cube. There is a link to Cube. There was 2-3 weeks ago, Cube Summit, and there was also at Scale Summit. So if you want to look at semantics from that perspective, they have it as well. So and then you'll understand what type of architecture choices you might need to do there. DBT metric flow was there in one way or another. We have basically the open standard with AtScale and Malloy. Funny enough, Malloy is built by the guys who actually built ML Looker with the learnings that they didn't want to do again. So that's that. And then we'll have basically the warehouse, the Databricks and Snowflake. Snowflake is, I forgot the name of, they have basically their own semantic generator inside Snowflake that it will actually help you generate the semantic layer. Now, I didn't work with that thing, so I don't know exactly how it really works, but it's provided within the warehouse. Resuming. So if we'll be an LLM, we didn't lose context. So the plot that is here is basically, if we look at what I mentioned, so what is the agentic readiness as well as like the AI side of it. So if you look at like what is the on the left hand side, you will basically see the heavyweights. However, you'll see that their AI/agentic readiness is relatively low. Now, this is a point in time. I'm not saying that this is what it will be in the future. However, this is kind of like where they are plotted against if we really want to go to our world. Again.
What do you mean when you say agentic? Like, what is that like? What do you want to do with an agentic system using an underlying semantic there, like versus human interaction?
So if the agent itself, you'll give it a task to do it for you, right? So it doesn't. So you're not is away from keyboard, right? So you're just giving the agent saying, I need this and this and this. Just figure out a way how to do it. That's basically what that means. It needs to have the access of where that information is, how it's structured, how can it access it, how can it query it, then summarize it, and da da da. So basically that workflow. So in this case, for example, in LookML, so how do you really access the LookML? So the DAX objects under the hood, or the Power BI objects, are they exposed outside Power BI? At this moment in time, I'm not aware of anything. So I said they might be there. I'm not aware of them. On the other side, I know Snowflake can provide you an API to access those things. But again, that's why they are high on the agentic readiness. They will be able to, for a system, in this case, an agent, to actually retrieve that information and try to build a workflow around those things. So that is that. So Semantido was built from ground zero for this because, as I said, I wanted my training to be agentic. Yeah. So I don't want to do anything. Just show it to me, and then that's it. It was so wrong. Anyway, and after this was better, but before it was so bad. So and that. So that's what I wanted to do. I wanted to see how can I build that agent and just have that learning, the curve to actually deploy one, see how it works. We'll go monitoring and things like that. We have a lot of stuff to discuss a bit later down the road from the point of like production systems. How do you know what it did do? What path did it take? All these things. Yeah. So this is it. So the article. Oh, I don't want to. I want to. Okay, this is it. So I spent quite a lot of time on this one. So it's 3 months in the making. So yeah, I didn't really use any models for. I used. So the interesting part is basically the structure that I was going back and forth, and I really didn't know how to. I know I wanted this way, but again, Claude was very helpful here. So it was a very helpful assistant. It told me I have great ideas every single time. I felt so good. I really did. I don't know why. Anyway, joke aside. But so it was that set. So there was dataset, rebranded 2023, is the most deployed semantic layer in the enterprise today. It actually predates the Gen AI era. It was not called like that, but this is what it was. We'll go through, there are different constraints. This is kind of like along the questions that you had. So like if you need a copilot for agentic, is copilot matching your, I don't know. What's the word? I forgot the word. I have a lapsus. I'll remember it. But the point is that I do have a lapsus. Anyway, so and then it's like if you want an adjacency to construct ad hoc queries. So that's what I was saying. So it to find itself the path. And how do we know that that query is correct? So the validation of the query, the validation of the response, and all these things. Is that possible? I'm not aware of that. So that's what I'm saying when I talk about agentic. LookML, Cube. So it was the coupling between the tool and the semantic layer itself. This is what Cube solved for. It was API. It's API first, exposing semantic definition via REST and GraphQL. But then you run a service with all the architectural illiness, like maintainability, scalability, availability, and whatnot, right? So they have their own offering, but again, is what do you want to do? I took it for a test drive. It's super good. So I'm not saying anything bad. It's just what's your poison, right? So if you want to run it yourself, then it's good.
Yeah. Tie it back together to what you started in the beginning, where you said I do mix martial arts and I want to derive insights from the data that I'm generating, and I just want to relate how these categories relate to that overarching objective that you want to derive these insights and you want to be very flexible. And how does that overarching goal compare to these blockers?
Well, initially I thought that I can use something. That's the point. I didn't want to use Power BI or something like that, but I wanted to use like Molloy or at scale, things like this. And the thing was that it's not that I didn't like them. It was a bit more of over-engineering for what I needed to do. And this is how Semantido came to life, basically. So and technically this is kind of like it's a looking back on the thought process of that, right? So that's why I wanted this tutorial to be based on, like, if you want to pick up anything, pick up like, so you don't look only at the tables, don't look only at this. It's much more than that. So because that was the mistake that I've done. I was thinking, I have the data. What can go wrong? Yeah, we'll see. Yeah. So and all these things, I didn't look at like DBT metric flow or things like that. So I came from data engineering. 7 years of my life, I built data warehouses and things like this. And I know they are good, but they are also bad at the same time, right? So is how do you handle those things? And I wanted something that it is good enough that I don't need to look at it every single time, but I don't want to spend an arm and a leg because I don't have the amount of, and the data is small. So what to do then, right? So, and how can we do that? So that is basically it. So this is interesting, and that's basically Semantido. Now we go into Semantido and we'll go actually to look at it and to see how it actually works. Now, that's what I said. So my whole world based on not only that. So that was the beginning. I had a couple of others after, but that was the beginning that actually triggered all this. And the reason I has no direct equivalent because it was built from the get-go with this in mind. So there was no, I don't say it's a special thing, but that was its positioning, right? So, and I realized that later actually. And then the Semantido treats the semantic layer as a part of the application itself. And we'll go into the code and see what that means, right? And I realized the table themselves would paint only part of the picture, and the application itself has a semantic meaning as well. And this is where this actually comes all together. So not only the table, but also how I generate that makes a lot of sense to actually put that thing in context. And that's basically what Semantido does. So if you want to do that in Prisma, if you want to do that in Django RM, that's exactly the same thing. So no, the knowledge is transferable. And rather than introducing a new service, which everybody else does, it actually relies on the SQL model, relies on what you drive your database from the get-go, nothing else. And most of Python data application use, since in the data part that I've done, most it was SQL alchemy. No offense, that's the thing. So a metric is not a separate YAML file; it's a decorated Python, and we'll look at the code in a minute or two, right? So it's not generating a side, because the other problem that I've seen is that yes, you bring a new table, but then you need to update the metrics. You have to be very disciplined. Yeah, so even with Cloud Code, it's not really that disciplined. So it will just sometimes miss things. So and that's a problem. Whereas in this one, it's there. If you missed it, there is a flag that you say enforce true. It will refuse to generate your Alembic migrations if you miss that description. And you can be as relaxed or as very strict with the system as you want, right? So if you bring a new table, in a table, a new column, and you say, okay, this table is very important, so I really need it to be exposed by the semantic layer itself, and don't forget anything, you can enforce it, and it will break your, by break meaning like stop your Alembic migration, say put the description there before you actually migrate the whole thing. And that is the point, that you keep the two in sync all the time. Your real system and your semantic representation of it will always be correct if you use that enforcement. If you don't, you might drift, but at the next time when you regenerate it, so hopefully that description will be there if you use a relaxed version of it, and then you will go. So it's a mixture, right? So you can always enforce them, but in some tables that you say, okay, those tables drive most of my business, well, you have to have them. Otherwise, it's pointless to go this discussion in the first place. So, and that is that. So this is where the picture comes from. So what is not good for, before we go into it, so it does not provide any caching. It's just the real deal. Yeah? So the system itself will provide the, does not integrate with any of the BI tools. I just built it myself, so I didn't have the time to do that. And is Python native by design. So if you do Scala, Warehouse SQL native, and that's not what you would want to use. So that's basically this. And the question that is most important is that the frame for evaluating is does this replace our semantic layer? So it does not. Is if you want to build this AI first capabilities, being able to an agent to let loose on these things, to better or worse. I'm more towards the workflows, and we'll see some in the code. Is like for Tim, I believe that for someone who will build an agentic system, and if you go look at agentic analytics, so the world that I envision is the following, right? And I don't have it yet to show, I tried. So think about it, yet another dashboard, right? So you will want to present some sort of an information somehow. Now, the question that I always had is that why I will need that dashboard always? Why can't I go into a UI interface, like even a chat, and say I want this particular metric, it plots me a graph, and I just create a dashboard with that. So it is my own interest. This is what I've done with my own tracking things that I needed to do for my things. I really wanted to know how many push-ups I do over time. And that was my metric. So I created a specific dashboard for that. I don't need, so because I do believe every single person or every single thing that looks at through a lens, through a business, has its own view. What is the metrics that are important to him? And right now, you are able actually to say, I want this. And just vibe with the thing till the metric is correct. Now you save it and that's your dashboard. That's what Semantido does, actually. That's what it enables. That's what I wanted for me. I have my own, the thing, and it shows me whatever. I'm not interested in those. No? So that's where this actually goes. It goes to the words to empower in a way or another agentic analytics. Now, enough with the slides. And so I think it's the last one. So that's basically what we had in the chat. Now I'll pull up some the examples that we have. So you can clone the repositories and do anything you want. Oh, that looks not good. So how do I change that? Charm settings. I think is the appearance is nope. I don't want dark. Do I want light? Ha, much better. Okay, good. So we'll go through, so the system runs in the background, and we'll go, what exactly does it do, right? So you will always have the models, and this is a bit of a thing how I will do it. So let's say in these cases we have mapping accounts. So if we look at the architecture, this exposes basically an app, a fast API route, and then we'll see what those are actually representing the endpoints of the semantic layer and how to interact with them. So account product map. So the first thing that you will have to see basically, and how do we bring these things together, is basically simple annotations. So you'll have across the tables, you'll have your SQL Alchemy tables. And this implements a semantic declarative base. It's basically, this is, so if you want to clone it, there are two repos, which is the UI and the SQL. So the code itself is, I don't know exactly how for you guys to get it, and you can start it and just play around with yourself. So that is the, how do I do this? Let's see. It shows up, yeah. So, and there are two repos. There's the UI and there's the backend. So let's see how this architecture comes together so that you will see what actually comes out at the end. So, so you'll have basically table names, which in some cases the class is correctly named, but the table name is ACCT prod map or something like that. And then you'll have basically two things what you'll see here. So you'll see the description, which it says bridge table tracking add-on products enrollment on accounts. This is what basically the description. This is what table holds. And you might have basically some examples of the SQLs. So if you want to, it's not really required. And then you kind of like guide what type of actions those tables support. Because usually you will see that there are different types of actions that you can do on the table, a join, a where clause, or whatever, so, and order by, right? So those will tell the LLM, hey, this table is mostly used with this type of operations. Now, you also pass synonyms to it. So what is actually the table? So it's an add-on, supplementary product, overdraft facility. So basically, you describe the table as good as you can. Right? So it's not always perfect, but you can iterate on the description of the table. Now this is an overdoing, sorry, but it's more than enough to just delete the SQL here, and then if you put it in a single sentence, it's not that bad. Then we have really the important part is the application context. So how this actually this table come to life? Yeah. So and this is on J. So use product catalog for any fee application to this enrollment. So map tables sometimes represent relationships between the two, and which are not clear to the language model most of the time. So you'll have to say, okay, in which application context this table is used. And then, for example, in this case, is never join this table for balance aggregation. That's an important thing. So this table should not be used for that specific path. So that is basically you have to do this work once at the beginning, and that's about it. You kind of like forget about it, unless fundamentally the table goes. Yeah.
But isn't this related to being in sync with your underlying data? Like being sync?
I will show it to you how it goes. So basically, this actually describes is what this table description is. So and what it is used for. So that is you'll have to tell the language model. Well, then, so the only thing that you need to keep in sync is that the description itself does not contradict with anything down the line. But the table fundamentally won't, I mean, it will have the same meaning, hopefully. You will need to put it in. It will, you'll use it yourself. So that's the thing. So there are two ways of doing this. Either a business analyst will work with you to actually put those things once. So it's about like describing it in a way that the metadata is exposed somehow. Now, as I said, you have two ways. You had a side-by-side file, so you have a YAML or anything else that you can put this thing in. This is what most of other semantic layers will do. But I thought that this is a bit better to have it actually at source itself and extract it from there. That's basically what this does. So you can have it both ways. So Semantido will be able to read from a YAML side to side. That is correct.
I think this gentleman asked this before, but did you start this documentation off with an LLM, or did you just do this manually?
You can use both. So you can start for having it so have a subject matter expert help you to guide that. And after that, you can actually enhance it with a large language model. That is actually how you should do it in the first place. Good catch, yeah. So the reason is that large language models are very good at language. So this is what they are. So basically, that will help you to actually bring a bit more clarity to the description of the tables. But the point is that it's a human who writes something, which is even a paragraph, a sentence, but then you can expand it to that point. And then after that, you'll have three things that are quite important, right? So one is the description. So it will tell you for that column what it is, what does it represent, and then it provides your privacy level. Now, that is interesting. So you will expose, for example, for systems that they do not have access to your internal data, you will only expose public. They will never, you can actually filter out what the SQL query can be if you say, okay, I don't want to expose any PII to my query, not the one that goes outside. So basically, it marks that particular column, so it has governance built in. So not too much, not too less. Enough for making sure that you're not sending something just by accident. So if you want to put it, so it's optional. The only thing that is required is description. That's it. So it's kind of like a balance. What do you want to do? And then, for example, you'll have examples. The other side is that what you'll see in the prompts is that example, few shot prompt example. Now, you'll see specific tables like, okay, just let's only generate the DDL and then have some few shots example, and that's enough. I don't think that's enough because it will not cover all the possible combinations that those tables will have. So it's becoming, so that is basically it. So it will tell you it has an example, a description, and a privacy level. It has a bit more components to it, but those are the three that I think they are the best ones to have.
Maybe you already explained it, but I didn't understand what does the privacy level do?
So privacy level will mark that particular column to a specific privacy level, public, internal, confidential, or restricted. So if you have a table account which will have your salaries, for example, in it, you want private or confidential for the salary number. So if an LLM will try to access that salary, unless it's not permitted to access private that particular type, let's say restricted level, it won't be able even to read it. No, so that is where I said production, because those you'll not get access to your entire database. Just just come to you, hey, I want your database, please. Not really, yeah. So you'll have some sort of a governance level in place, either through access-based or role-based access controls, to be able to run those things, right? And that's basically what it is. So that it will allow you to do that. And all those tables will just actually map like that. You'll have transactions. It will tell you synonyms for that: full transaction ledger, every monetary movement against an account. And there is, by like a sign conventions, amount is always stored as a positive number, but it counts on direction, right? So it will always be amount, it will debit, credit, it will always be 1,000, but you have to be 0, right? Yeah, so when you sum. So that's kind of like important things that usually this type of applications have. And then you'll have where, join, order by, and group by. So those basically are telling the LLM helping it how to construct it. So that is basically what Semantido is in a nutshell. That's it. Kind of like that's it. Yeah? So now what can we do with it? The what? That's what I'm talking about. Now, so we go back to basically the agentic part, right? And then so the agentic part is basically you'll have, let's go in the app. So if we go to, I think we just switched to the, where's this one? This one needs to go up as well. Let me change the setting of this one because it will be dark as well. Settings, appearance, and then we go Iceland light. Okay, so this is basically the front end, and the front end is totally vibe coded because I don't know that much of a front end, so bear with me on this one. Yeah, so it's basically, how can I do it? Is here, right? So you'll have streamline. And you'll have basically two modes. It will be a user and an analyst. So if you choose to, that will be actually the permissions behind the scenes. And this is how we'll go in the harness, and we'll describe what the harness does in this place. So the user will be forced to answer questions only pertinent to that user, whereas the analyst has a bit of more permissions, and it lets the system actually allow the system to be a bit more, let's say, open to, not open, to access more tables, let's put it this way. So if we go back here, basically there are in the world today, there are two considerations, right? How do you really build agents? You build them as a deterministic and non-deterministic. In some cases, for analytics, they must be deterministic. Or in some cases, you can let them loose, but the example today is for a deterministic system. So you'll have basically so we'll talk about context. So how we configure an agent. So it will have basically the Postgres client access to the database and the semantics that we attach to it. And most of the cases, you'll basically see that the semantics are passed very lightly. And then we'll see what actually Semantido generates. Now, you'll always know that, and that's why I like Pydantic AI. You can generate either a data class or a Pydantic class, which will have the structure input and structure output between the parts of your orchestrators. And that is quite interesting compared to other, say LangChain or anything like that. They do have a, like the pipe, and then they kind of structure the things. But this one says, okay, but what if my input and output are different? And I really want them to, so this has this input and this output to this agent and whatnot, right? And then in this case, you can build as a data class a workflow context. We have like an ID, a user ID, what type of it, the agentic configuration, the query type, the reason, the sanitized query, the generated SQL query. You'll see that basically there is a kind of like a workflow that actually you won't let like show me all the data. That will be blocked, right? And then we'll see how. So those things are basically the harness around the SQLs themselves. And then you have like the conversation history. So how do you maintain the context and da 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 da. So this is it. So we'll have different steps, and this is basically what the harness is in a nutshell, right? So we'll have a classify user query, which will look like so it has also like the query usage type and whatnot, but it has a classifier, in a way, classifier agent, right? So it looks like what is the intent classifier agent, right? So we'll go in here and we'll see, okay, we have, so it should be, so you'll have, and this is how you actually layered your harnesses, right? So, and one of the things is that like the query classification. So it's a description. What is the reason for that? So why it classified it like that? You might want to know. You always track those things. So in order to be able to see if your agent actually works correctly or not, and then you'll have like the sanitized query. So basically, if there is something that it's okay-ish, it will actually try to remove anything that might be, funky. So it says a clean, security validated version of the user original, any potential SQL injection attempts, encoded payloads, and da da da. So you have to have these ones at every step, right? So it's not that you just shovel it in and go with it, right? So this is the second step in the defense of your agent. So the first one is actually look at it from the intent perspective. That is correct. That's correct. Yeah. So, sorry? Oh, okay. How do I? Does this one? I think there is a way how to increase the font. There was a font settings in PyCharm. I tried. Sometimes it doesn't really. Size, let's make it 17. Better? No. So, and then you'll have different intent prompts. So if you look at the agents themselves, we can call them sub-agents. You have an intent validator, and you have what's called basically a prompt library. And then you can keep a track of your prompts as well. So this is a file. This is basically in a Python context. However, you can do it however you want, right? So you'll have like a domain overview, so customers, accounts, products, transactions. So if you ask, for example, what's the time in London now, it should not actually answer you, or build me a Next.js website or things like that. So it's actually, which did happen, right? So there were agents. Don't use OpenAI. This one you can do it for free. Yeah. So I don't know. So basically, this will validate the intent, and then it will you can build this with an LLM as well. So you can use an LLM as a judge as well as yourself. So you can make this ones quite easy with a large language model. And then you'll have basically your SQL generator, so agent. So this will be the one that actually is responsible for generate the SQL. And then you'll have the prompts for that, and then you'll see that you'll have pre-built agents instances for the user and from the analyst, because there are two different roles. So they will have two different prompts. One will be, if you look at the context of a user, you say, okay, the authenticated customer ID is this one. All queries must be scoped to this customer. So if you pair this with row-level access controls or access-based controls, then there is no way that thing, unless there is another, I cannot see another one, how you can actually access other data. So basically, you're restricting within the prompt and within the system, the access to that data. So if you do this via Neon or via Superbase, they have row-level access controls. So even if you try, you can't. No? The system itself won't be able to do it either. So whereas in the other case, for example, for the analyst, it does not have that. Or you can build the prompt a bit differently, but it will be able to look across the users, because this is what you'll be interested in. Show me the, or whatever the queries that we looked in a couple of seconds. So that's basically what at the end of the day this does. And then you can have some few shots prompts, like the join path rules, no customer attributes are required, join directly from account info. So this is again where people with knowledge about the systems are very important. Without that one, it won't be able to infer that knowledge. So you can write it with an SME, and then you can rewrite it with an LLM, as you mentioned. That is the best way to do it, I think.
I'm just saying, like, do you have any experience, like real world experiences where like this was, because for me this is the most fundamental thing, right? Like basically encapsulating the knowledge. This is the semantic layer, right?
Yes, this is exactly what it is.
What the human understands, so that the agent also understands.
Yeah.
And now we're kind of like doing it kind of manually and verifying it with the LLM. But do you have any insights on how we can make this more frictionless for the end customer?
Not really. I mean, the very first point of getting that data in one way or another, that will be a friction point. So, and if you think about it from the big data world, so we had 10 years to actually sort things out, to attach this metadata for 10 years. So this is only exacerbating to the point that actually people require that metadata now. In the past, there was like wishful thinking, a project. I was in data engineering, so that's what I'm saying. That was the last on the list. Metadata on the table, forget about it. Yeah, oh shit, I'm sorry, I'm on record. So, but yeah, so so that's the thing. So whoever was smart enough at that time to build even a small catalog, they will be far ahead of this. There is no way around it. Like fundamentally, I don't see one. I do this for 8 years more. So this is, and that will be the friction point. You had 10 years to do it. No excuses now. In my own view. So that's, and also organizational. I'm not speaking to anyone. Yeah, but that's basically what I'm trying to say. And that knowledge is very important because we see these days like, oh yes, the large language model can do everything and anything. No, they really can't. Without that information, without that specific knowledge, that business and application context, they can't do that. There is no way. Unless you're AI native from day zero and then you build that thing somehow in. But who is it? This thing is 2 years old, 3, if you really want to be, like really specific, yeah? So that's that. And those are basically your harness. So if you look at the application itself, and I don't know why this one clicks wrongly, you'll have basically initializing the semantic layers, and let's see how actually this one looks like, right? So what is it behind the scenes, and then we'll fire up some queries to see that if it really works, right? So if we look at the localhost, let's get another one and then start the 8,000. Moment of truth, if this works, right? I talk about for like an hour and stuff, and then that doesn't work. That would be very bad. So that's basically your semantic. This is your semantic mapping. So this gets actually injected in prompt. Not this, the markdown. We look at a nicer representation, but for saving tokens and whatnot, you would go to markdown or something that it allows you a lower token consumption. That's basically it, and you'll see technically everything here. So the relationships between the table, the description between the tables, and then you can even go a bit further, and you can apply semantic searching or semantic filtering to reduce the space to only the tables that you want. Now, because this is a small example, you can say, okay, I can fit it in the context window. Now, if you have 100 tables, obviously you will want to prune that one and say, there must be a way to kind of like go it down for that. But basically, it tells you like you're pending, verified, because they might say, show me customers, and then the customers who? Customers who are active. So that answer should be clarified, right? KYC pending. And if you start to say, okay, show me the, give me all my customers. Well, all customers, as we saw in that fan out, the first place, it will tell you sum over all your customers. But is that true? No, because there are pending ones. You should exclude those ones. So it's not because show me all your customers, what your intent is, show me your active customers, potentially. That's most likely what your intent was in the first place. Things like this. So that's basically what this is. So it provides you it provides the LLM with that particular understanding of the world. Now, for the failure path, so and if you go into the repo, it will actually. So long story short, how you do it? It's UV based. You will do a UV sync and then UVVNV, and that's about it. And I should do a bit of more README. I didn't have the time to do it really. It's the README, and I didn't use Claude to do it either, so my bad. But you'll have the data itself. You'll have the seed data. So it will once you run the Alembic migration, the upgrade head, you will seed this, and then basically you will get the data into the database, and you'll try to play with. There are some questions, for example, and then basically is a bridge fan out. So this is how your evals will pretty much work, right? So you need to generate some sort of a question to test your system and see what is the correct path. So if it will be a naive, broken route, or it will be a correct route, right? So and we can try this. Show me the average account broken by product category. So if we go back to the Streamline to the Streamline app. And then we should get the SQL query. We'll see that it's approximation. Let's see. Ooh, shit. That is not cool. What did I do? Why? Backend error. Database client is not initialized. Why? That's what I didn't test before I started, but it worked before. So let's see why. Why is this one? Was initialized. Did this one? Where's my mouse? Okay, let's see. Okay, so we should be all good. Maybe it was a timeout. Let's try to do the same. Did I have it still in the? Nah, that is not cool. Why? That is something that I did not expect. Okay, so this, okay, let's see what is this one. But which service is unavailable? The service is started. So we have 4 minutes. I'll try to debug this, why this is not the case, and I need it not to move my neck. But why you're not starting? The connection is there, so Semantic analyst. So. WebStorm back. See why that was database client not initialized. That's something that stops me. So let's see. So we have a database client, and let's test the client. If the client goes online. Okay. Test again. Okay. So let's restart the whole thing. And rerun. Come on. Okay. Magic. Come on. So I think something happened on the Neon side. So apologies for that. I think so I use Neon new, which I think the database expired. So one of the things that you can use to test is like neon.new. So it's kind of like it gives you a database for a couple of hours. I think that expired. Okay, so there is one small error that it was in there. So the normalization of the URL was not correct. So, and that was a failure. And it's a fix URL norm normalization in test. So, okay. So I pushed two things on the repo that had so the database is connecting, and this is what I'm not seeing what was the issue. So if you look at the tests on the Neon client, so if I run this, it tells me that I can get a connection to the data store. However, the URL scheme is correct, the tables are there, and connection is closed. So for whatever reasons, the front end doesn't, so the application itself does not connect to it. Let me see why. But if you do that, it will generate that SQL that you'll actually look at. I tested it before. I woke up at 6 in the morning to do this, and as usual, the gods of demo doesn't work. So my pleasure. It's just I'm a bit concerned why this all of a sudden doesn't work.
I would like to thank you, Dragos, for a very nice talk. Think about the lots of explore later. I guess we can find you here all.
Yes, I'll be here.
And as a thank you on behalf of Pydata.
Oh, thank you so much. Oh, I'll talk to this duck a lot.
Yeah, so thank you very much.
Much appreciated. Thank you for attending early in the morning. As I said, I'll see why the issues will be, but my aim was for you to learn the principle of semantic layers, and Semantido is a side note to it. But if you have an understanding of what that means, the agent harness is there for whatever reasons refuses to start. Yeah. So, as always. Thank you so very much. Much appreciated.